Hi everyone, we are on to connective tissue again, and this time we're on to bone. So we've already been through connective tissue proper, which involved dense connective tissue proper and loose connective tissue proper. And we've already been through cartilage, and that involved three types of cartilage. Cartilage are hyaline cartilage, and elastic cartilage, and fibrocartilage. Now we're on to bone. And when we talk about bone and a new set of connective tissue, we talk about its function first, because the more we know about its function, the more that we can predict its form. The reason we're doing it this way is so that when you see on an exam a microscope slide, you'll look at the form and then you'll reverse engineer it back to the function, and you'll identify the tissue by the form and the function back to the tissue. So we're going from tissue to function to form for you to study by. When we talk about the bone tissue, this is something that you're obviously very aware of, and we're going to dig deeper into this now, into the function, because you know that bone protects your organs, particularly your lungs with your ribs, and your pelvis protects your kidneys and your reproductive organs. You know all that. And you should also know that bone supports organs throughout the body, and that support is functional because bone supports skin, and skin is your largest organ, as skin is for all vertebrates. And you can also know that that bone supports your nerves because you have bones all the way up and down your spine, and they are supporting your spinal column. So bone supports organs functionally, and bone supports organs nutritionally. Bone is the reservoir for calcium, magnesium, and for phosphates that you need in order to catalyze reactions throughout your body. Calcium and magnesium, important for heartbeat, and every other cell needs them as well. So bone is the reservoir for your calcium, magnesium, and organophosphate stores, and we'll learn more about that. Immunologically, bones support organs because bones are the warehouse where blood cells are made. Those blood cells include white blood cells. Oxidatively, bone supports your organs because bone is the warehouse where red blood cells are produced as well. Hemodynamically, bone supports organs because bone marrow is the place where platelets get started. And so platelets act to stem blood loss by clotting off injury. Let's explore each of these very important functions in terms of bone connective tissue. When we're talking about bone, of course, it's divided into different types of bone. We'll look at compact or dense bone first. That's the one you know of that breaks. And we'll look at spongy bone second. When it comes to compact bones, there are locations for that at the shaft of long bones. This here is a graphic that shows you long bones in red, so that when we talk about dense bones, we're talking about the shaft, the middle section of these long bones, the femur, the tibula, the fibula, the humerus, the radius. So when we talk about compact and dense bones, we're not only talking about the shaft of those long bones, but also the external layer of all bones. We'll get into the specifics of that in a second. If we go back to our wolf, we are looking at bones as a set of connective tissue that will support the skin that is around that is around that long bone. And in terms of the function of these compact bones, the compact bone type, they are supporting organs functionally, and that means that they are supporting nerves and skin. They're supporting those organs structurally as well by holding them in place. And nutritionally, because the compact bone is the site where the calcium and the magnesium and the phosphate is going to be housed. In addition, bones protect organs from compression, so that your pelvic girder is a set of bones that protects your kidneys from compression and protects your reproductive organs. Same thing with your with your ribs. They certainly protect your lungs from compression. When we look at the form for those hard, compact bones, we talk about the form that is within inside the bone. And the form is a cylinder. And there are many of these cylinders. The cylinder is called an osteon. It is a cylinder of calcified bone material. And there are osteons throughout the dense bone. In fact, I'm seeing here probably about 20 to 25 osteons right where my mouse is. So these are all cylinders that fit into the hardened bone, the calcified bone. Let's talk a little bit more about the osteon and the form of the osteon, because it's quite complex. When we look at this, the form of this very functional calcified bone, we see it made up into different areas. And this osteon cylinder actually has rings to it. And this is an osteon right here. And you see the rings. These rings are concentric rings that move out from the middle. You see that. Those concentric rings are called lamellae. And there can be up to 20 of them per osteon. This one in particular is showing 3 lamellae. But generally it goes from about 5 to 20 rings of lamellae. Those lamellae house the lacunae, or the multiple lacuna, the pools of cells. In this case, for calcified bone, the cells are osteoblasts, which blast off and create the osteocell, osteocytes, which are the bone cells, the cell itself, and osteoclasts, which take and remodel the osteocytes into cells that can repair broken bones, repair injured bones as well. So the lacunae, which are in the lamella, and the lamella house the pools that house these osteons. You can see the osteocyte nuclei right in there. Are a pool that houses all 3 different types of osteocells: the blasts, the cytes, the clasts. In addition, the lacunae also will store minerals, will store the calcium, the magnesium, the phosphate compounds in between the cells. So there's a lot going on in the lacuna that are housed within the lamellae. It goes even deeper than that. When we talk about these lacunae, obviously they are cells that are changing rapidly. They need a continuous nutrient stream in, and they need to carry their wastes out. The function of moving the nutrients in, the wastes out, is done by the canaliculi, which are small canals that are at right angles to the lamellae. Let's explore. You can see it I guess you can see it here best. So these lamellae are surrounding are within the osteon, and I would say you can see at least 1, 2, 3, 4, 5 lamellae in that osteon. The canaliculi go in right angles to the lamellae. So what you're seeing here in terms of right angles to the rings are the canals that are bringing in nutrients and removing waste. They move from the matrix into and toward the center of the osteon. When they move from the matrix toward the center and of the osteon, they are moving towards what's called the Haversian canals. The Haversian canals cut through the middle of the osteon. You'll see them right here. They go parallel with the cylinder of the osteon, and the Haversian canals carry the arterial blood vessel and the venous blood vessel, along with nerves up and through the osteon. In doing so, there will be some crossovers between osteons and between the circulation of the osteons that comes in with the Haversian canal seen vertically here, and the transmission between osteons is via the Volkmann's canal. The Volkmann's canal can connect to Haversian's canal and can connect osteons. And that Volkmann's canal can bring in nutrients, pass nutrients, and it's a branch for nerves between the osteons. Very important so the osteons can talk to each other and communicate in order to repair injury quite quickly. When we are looking at, and let me move this over, when we are looking at the osteons, we recognize that there are plenty of osteons within the compact bone. But what is around the outside of the compact bone? That area is called the periosteum, like perimeter around, periosteum around the bone. It is the outer covering of all bones, and it is compact and dense. And the endosteum is for in. So this is the internal covering of the compact bone. It's the inner lining of the compact bone, which is really noted by the osteons that you see there. Just to go back, when you see a microscopic slide showing round circles with a central canal, you think osteons and compact dense bone here. And you probably will not see a microscopic slide that has the periosteum around it, though you might, and you might see some environment beyond that. And the endosteum is the internal side. Inside of the endosteum is the spongy bone, our second type of bone. We're going to get to that now. Our second type of bone, the spongy type of bone, is really very well protected inside the dense and compact bones. And these very well protected areas are form follows function. So let's look into what we're talking about. Then we'll look into the function of that area. Then we'll look into the form of how this spongy bone works. Spongy bones are at the ends of long bones, at the ends of your femur, at the ends of your tibia, at the ends of your radius, at the ends of your clavicle as well. At the ends of long bones, you will find spongy bones. At the ends of hip bones, ribs, vertebrae, sternum, all of the bigger bones of the body at the ends will have spongy bones. And there's a twofold function of that. It adds a little bit of compressibility to the ends of those long bones to protect